Okay, so we're considering a side-by-side bar graph for the conditional distribution of degree received given sex. The sum of the heights of the bars across degrees for men should be 100%. The sum of the heights of the bars across degrees for women should be 100%. Height of green bars. Associates given women. So you take the value divided by the number of associate's degrees, and then you do that for bachelor's, master's, and professional's degrees given to women. You divide the value by the total number of that level of degree given. So for example, professionals given women, the value is 97 and 2,283 degrees of professional degrees were given to women. So you divide 97 by 2,283 to get 4%. And you're using the marginal total to get the 2,283 because you only want for the women level of sex, not the total number, because you're comparing women within themselves, basically. Another way we could plot the conditional distribution of degree received given sex. So this one shows that the 4-level variable is now being plotted. So the associate, bachelor, master's, and professional or doctorate degree. So now you have, for men and women, you have like each of the 4 degrees for men in a cluster side by side, and each of the 4 types of degrees for women in a cluster side by side. So when you're looking at this, you can basically tell what type of degree men got the most and least frequently, and what type of degree women got most and least frequently. Okay, now we can see the other conditional distribution for the 2 variables, which is the conditional distribution of sex given degree received, graphed in a side-by-side bar plot. The sum of the heights of the bars for men and women for each degree type should sum to 100%. The height of these bars, women given associates equals 639 divided by 1041 equals 61%. So when you're looking at women given associates degrees, you take the number of women, 639, and divide by the total number of associates degrees to get the 61%. And so like for men too, you would take the total number of men given associates degrees and you would divide it by the total number of associates degrees given, which should be 39%. Okay, so now we can see a comparison of the 2 side-by-side bar graphs for each conditional distribution for each of the 2 variables, sex and degree conferred. So the first one is conditional distribution of degree received given sex. The second one is the conditional distribution of sex given degree received. So for the second one, the sum of the heights of the bars for men and women for each degree type should sum to 100%. Okay, so the one that is about degree received given sex, you can see that if you total all of the percentages for the male bars, you get 100%, and if you total all the percentages for the female bars, you get 100%. And for the second conditional distribution of sex given degrees received, so it's about sex this time, you can see that each side-by-side bars chunk of men and women will total 100%, like for an associate's degree or any of the other degrees, they all total 100%. So it's kind of the opposite of what you would expect in a sense. So for the conditional distribution that's about degree received given sex, the bars by sex total 100%, and for the conditional distribution of sex given degree received, the bars by degree level total 100%. So I guess that's a function of how that they're interrelated in these percentages. Other plots to show conditional distributions: mosaic plot and segmented bar graph comparing the proportions of women green and men blue among those in each degree conferred category creates a conditional distribution of sex given degree. So what's interested in the one about degree received given sex highlights the sex differences more than anything, and the one about sex given degree received highlights information about the degrees, what proportion were male and female of each degree category level.